Hi students, today we will discuss about the torque acting on an electric dipole. Torque acting on an electric dipole. Now here one dipole AB, this is placed in an uniform electric field. The electric field is E. The dipole AB, this is placed in an uniform electric field E. The length of the dipole, that is AB, is equal to 2A. Now when this dipole is placed in the electric field, so here this plus Q charge will feel a force due to the electric field, and this minus Q charge also feel another force F. This magnitude of these two forces acting plus Q and minus Q both will be equal. Why? Because the amount of charge is same and the electric field is also same. What is the difference in between these two forces? These two forces acting oppositely directed. If on the plus Q charge the force is acting along this direction, then on the minus Q charge force will act along this direction. So such a condition, when two forces acting on an electric dipole opposite to each other, then a torque will act on this dipole. Now we will calculate what is the value of the applied torque acting on the dipole. We know torque, that is defined by tau, is equal to any of the force, that means in between the two force any one force will take, into the perpendicular distance between the two forces. Perpendicular distance between the two forces. Perpendicular distance between the two forces. Now we can write tau, any of the force means write F. So this force F and in between this force F, this is the perpendicular distance, that is BC is the perpendicular distance. So you can write here F into BC. Now we know that if Q charge is placed in an electric field E, then force F is equal to QE on it. So tau is equal to the value of the force, that is QE into BC. Now from this diagram, if you see from triangle ABC, we can write BC by AB is equal to sine theta. What is theta? Theta is the angle between the dipole and the electric field. When the dipole is placed in that electric field, then the dipole make an angle theta with the electric field. So from this diagram from this triangle ABC, BC by AB is equal to sin theta. So from here you can write BC is equal to AB sin theta. So from here BC is equal to, the AB means the length of the dipole is 2A, that is 2A sin theta. Now we put this value of BC in this equation. Therefore you can write tau is equal to QE, and the value of BC is what? Twice A sin theta. So from here you can write tau is equal to 2A into Q sin theta. So what is the meaning of 2A into Q? Previous class we discussed about it, that length of the dipole into any one of the charge is known as the dipole moment. One E is here, this E. So from here you can write tau is equal to 2AQ means the dipole moment P, and that is E sin theta. So from this you can write in vector form, that is P vector cross E vector. So this is the expression of torque acting on an electric dipole when it is placed in an electric field. So this is the expression of torque acting on an dipole when it is placed in an uniform electric field.